Prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. So the difference between the squares of two consecutive odd numbers. So if my odd numbers are 2n plus 1 and 2n plus 3, those are consecutive odd numbers. The squares of those numbers are like that. And if I want the difference between them, I want to do the bigger one take away the smaller one. Okay, expanding these brackets then. Right, 2n times 2n is 4n squared. 2n times 3 is 6n. 3 times 2n is 6n. The 3 times the 3 is 9. Then, expanding the second set of brackets, we've got 2n times 2n is 4n squared. The 2n times the 1 is 2m. The 1 times the 2n is 2m. The 1 times the 1 is 1. We can collect up some like terms here. The 6n and the 6n is 12n. The 2n and the 2n is 4n. So far I've shown that this is the same thing as this. And this is the same thing as this. And now I need to deal with the fact there's a minus in the middle there. Really importantly, I need to subtract all of the 4n squared plus 4n plus 1. So I need brackets around it. If you don't put brackets around that, you're going to make a mistake. Because like I say, it's not just the 4n squared we're going to take away. We're going to subtract the 4n squared, but we also need to subtract the 4n and we also need to subtract the 1. If you don't put the brackets around that, you might forget to subtract the 4n and the 1. Right, so let's do that. The 4n squared minus 4n squared is 0. They cancel out. The 12n minus 4n is 8n. And the 9 minus the 1 is 8. So 8n plus 8 is the difference between the squares of any two consecutive odd numbers. I need to show that's a multiple of 8. So therefore, let's factorise 8 outside to allow me to write the conclusion, therefore, a multiple of 8.